Hi friends, this is Alok from meherclasses. Welcome to the fourth lecture on set theory. Till now, we have seen different types of sets and their applications, and as promised in my last video, here I am with the proof of De Morgan's laws. If you're new to this channel, please find the links of the previous videos in the description below. So let's get started with the De Morgan's laws. The first law of De Morgan says that the complement of the union of two sets is equal to the intersection of their complements. Mathematically, it can be denoted as the complement of A union B is equal to A complement intersection B complement. The second law says that the complement of intersection of two sets is equal to the union of their complements. So mathematically, I can write it as A intersection B complement is equal to A complement union B complement. So let's see the proof of these two laws. To prove the first law, that is A union B complement is equal to A complement intersection B complement, let's assume an element called X. And let's say that X belongs to A union B complement. So if by any means we could prove that this X also belongs to A complement intersection B complement, the first law will be proved. So when we say that X belongs to A union B complement, clearly X does not belong to A union B. And also X does not belong to A and X does not belong to B. So if we say that X does not belong to A and also X does not belong to B, we can say that X definitely belongs to A complement and X belongs to B complement. And to simplify this, we can also say that X is also the element of A complement intersection B complement. So here you can see that this X was the element of A union B complement, and now we have proved that X also belongs to A complement intersection B complement. Hence, the first law of De Morgan is proved. So let's prove it with an example. Let's say we have a universal set with the elements 1, 2, 3, 4, 5, 6, 7, and 8. And we have two random variables. We have two random sets A and B with some random numbers to it. Let's say A has 2, 3, 4 and B has 1, 6, 7, and 8. So first of all, you need to find out the complement of A union B. And to find this, first of all, find A union B. So let's take the union of these two sets. We get 1, 2, 3, 4, 6, 7, 8. And A union B complement would always be equal to the difference of universal set and A union B. So if you solve this, you will get A union B complement is equal to 5, because you will need to consider only the elements of this set and not of this set. So 5 is the only element that does not belong to this set. So A union B complement is equal to 5. Now you need to find out A dash and B dash as well. So A dash is equal to U minus A and B dash is equal to U minus B. So this we already have learned in the previous videos. So you need to take the difference of the union, the universal set and the set A. You'll be getting A dash. So 1, 5, 6, 7, 8 would be A dash and 2, 3, 4 and 5 would be B dash. So we can say that A dash intersection B dash, we need to see this RHS, and that comes out to be 5. Looking at the equations 1 and 2, we can see that the values are 5 for both the sets. So A union B complement is equal to 5 and A complement intersection B complement is equal to 5. Hence, A union B complement is equal to A complement intersection B complement. So this is how we proved the first law of De Morgan. Now let's prove the second law of De Morgan. What it says? It says A intersection B complement is equal to A complement union B complement. Moving along with the same pattern, we would consider an element X and we would say that X belongs to A intersection B complement. So X clearly does not belong to A intersection B. And also X does not belong to A, or X does not belong to B. Since we have intersection, so it corresponds to OR. Then we can say that X belongs to A complement or X belongs to B complement, because X does not belong to A or X does not belong to B. So we can also say that X belongs to A complement union B complement, isn't it? Since X belongs to A complement or X belongs to B complement, we can say that X also belongs to A complement union B complement. And hence, we can say that since X is the part of A intersection B complement and X is also the part of A complement intersection B complement, this law holds true. So the second law is also proved. So let's prove it with the help of an example, as we have proved in the first law. So we have taken the same values U, A, and B. In U we have 1, 2, 3, 4, 5, 6, 7, and 8. In A we have 2, 3, and 4. And in B we have 1, 6, 7, and 8. So A intersection B complement. We need to find out this first. So let's say that A intersection B is equal to 5, because there is no element in common. If we take A and B, if we take the elements of A and B, we can see that no element is common between A and B. So A intersection B would be equal to 5 or empty set. So to have LHS, that is A intersection B complement, we can say that it's a universal set, because in the previous videos we have seen that complement of nothing is everything. So A intersection B complement is equal to U. So A intersection B complement would be equal to the universal set. In the same fashion, we need to find out A complement and B complement. So we already know the formula that A dash is equal to U minus A and B dash is equal to U minus B. So we could say that A dash is equal to 1, 5, 6, 7, and 8. Similarly, we have B complement as 2, 3, 4, and 5. So if we see the equation number 1 and equation number 2, we are getting the universal set for A intersection B complement and for A complement union B complement. So we can say that A intersection B complement is equal to A complement union B complement. So thank you for watching this video. Please like, share, and subscribe if you find this helpful. We'll be available with something interesting very soon. Till then, have a great day. Thank you.